when you replace it with air supply, that can't happen. So pretty much I just do this slowly to allow the mold to drink up silicone. So this, oh man, there's a dog here in here. Told you. So this process should only take about 10 minutes. Unfortunately, this silicone, has about a 20-minute pop life, so if you do take your time, this silicone will cure on you. Yeah, well, it will gel on you and not go into the mold. It won't cure for a while, so you'll just be staring at it and not able to do it. But there are things called retardants that will slow the cure of silicone. So if you find yourself, like, you're in Arizona and your lab's always really hot, and your silicone's going to cure faster. And so there are lots of ways to slow that cure. And then if you're, say, in Alaska, and your lab's always really cold, there are ways to speed it up with accelerants. Myself, I've just tried to learn to get the techniques down in enough time that I have working time for the silicone. So I've got to have enough time to get it in there, and then also vacuum degas the pocket before the silicone starts setting into the gel phase. So I can probably go a little faster. And so pretty much I just do this process until the mold drinks up all of this silicone. And you can jiggle the mold around a little bit to try and make any air bubbles. Rather than do that, I vacuum degas it, but jiggling it, tapping it, there are these things called vibratory tables, which just do the job of jiggling for you. That's pretty dang close. And so since this doesn't have another wax side in it, it takes about twice the silicone.
I mean, you gas it once the silicone is set.
Oh, you don't do it once the silicone is set. While it's still liquid, you degas it, you put it back in the pot and degas it once more. But you have to do it quick because the silicone might set on you. It's a little bit like a souffle. So we're looking pretty good here. This might need some more silicone. I might have just blocked up the hole, but you get the idea. So there's that guy. Bubbles. Yeah. So it probably is going to bubble a little bit because I didn't take my sweet time and care as much as I might have. But when you get some cloths, so I don't get everything in the universe moving sticky, you'd be amazed at how many paper towels special effects studios go through today. Or maybe not, but we had these giant rolls of paper towels because everything needed to be cleaned. Everything makes some sort of mess, or it was a brush that needed to be cleaned off, or it had some sort of gunk that would cover anything on the planet. And one of my favorite aspects of special effects was how much the mold-making people hated the machining people and vice versa. I worked as a machinist, and there was an enmity between the mold-making side and the machining side, because everything the mold makers did would turn into an adhesive. It was a sticky adhesive that would completely screw up any bearing surface or any press fit. And all of the things the machinists were doing would completely foul a plaster or a plastic. So all the casting stuff, if you got some oil into a plastic, or if you got some oil or metal shavings in, if you got aluminum shavings into the silicones, it would cause them to cure in the pot. And so, damned if you do, damned if you don't. There's like a silent fight going on between, well, not so silent. At times we launch ball bearings into the mold making shop, but that's not going to be enough. This isn't going to turn into an official clock.
Oh, all right.
We'll just sort of wink and nod. Because it only has the half the wax.
Oh, yeah.
So I can show you one I prepared before, so you get an opportunity to look at the internal structure. So what remains to be done on this one is to wait. So it's best to wait with the cup that you poured out, so you can check when the gel time happens. And so this part gets peeled off and gets replaced with this part. It's left on the back, and then you just pour the other layer of silicone in, and then you wait a full 8 hours for the whole thing to cure. But in the true culinary tradition, I have one I prepared earlier. And so this is a demonstration of what lives inside one of these guys. This one, if you food. Hooray for food. Anyway, so this is one that I've filleted to show you the inside geometry. So I have a lot of these guys that, you know, there was a bubble here, there was a thing there, so I thought I'd take one that I was going to throw away anyway and show you what lives inside. And so if you want to take a look at this, let me de-stick it for you so you don't get stuff all over yourself. Actually, there's a vague chance that we have baby powder somewhere. Baby powder is a really great de-sticking agent.
Still recording? Yeah, I'm impressed. And it doesn't feel overheated either.
Seems like a bad idea. So, if I remember it right, deodorant is a combination of talcum and aluminum oxide. So, there we go. Secret recipe.
So what was wrong with this one, and how did you know it was wrong?
So this one, oh, that is one. So this one had some bubbles gathered up here. So on the first casting, it was pretty bubble free. On the second casting, there were some bubbles that accumulated here and here. And they communicated with the inner geometry. And so unfortunately, I couldn't salvage that one. One of the biggest problems with this particular manufacturing method is that a small bubble or a small, it's almost like the heart. A small join between things that shouldn't have been joined change how the flow goes and completely interrupts the structure of the order. Because it's very seldom that you'll have an accidental communication between the same side of the wax. It'll communicate with the other wax, and then the whole thing just blows up simultaneously. So if you'd like to take a look at this one, it's not so sticky anymore. This guy has a chance to actually play with this for himself.
How do you make different colors?
So there's I think it's really just pigment and silicone oil. There's a product called Silk Pig that is different pots of essentially silicone paint, and you can mix them with your silicones to tint them. And so I like tinting them because it makes, like this one sort of has an odd shape to it, and it's a little bit more hard to parse, and I find that the even blue tint of the one that I use for demonstration purposes. Unfortunately, having been around the world a couple of times, this one eventually developed a hernia.
Did you put the tint in before you do the mix? Did
Yeah.
you make sure that they really...
So what I do is I put the pigments in part A, mix them up, part B, mix them up, and then I mix A and B to make sure there are no streaks. So if you want, you can give these a try out. Just be very careful not to overinflate it. So these are signal manometer pumps. So the idea is these valves control whether or not air goes in. So they're bleeder valves. So all the way to the right is locked, and so squeeze it, and that puts air in, and then if you twist, it lets the air out. Thank you.
Very strange.
Yeah.
So how did you make it walk?
So that one's walking behavior is not as hot.
Okay.
This one was my champion here.
Okay.
But the general thing is you inflate it enough and it starts, again, ever use a signal manometer? Ever use the blood pressure cup?
Yeah.
It's the same valves on there. And so what gets it to walk is you inflate it enough that it starts bending the legs. I might be able to find for you my favorite video. Yes.